All right, hopefully this is recording. I'm doing this on my Mac at home, which is a kind of a new thing for me. But welcome to more physics tonight. All right, so can't resist a dad meme up here. Looking for some good things up here. Yeah, electricity and magnetism. They have some similarities to them. You can see positives repel, negatives repel. Opposites attract, though. All right, so we're going to kind of try to bridge the gap about how electricity and magnetism have some similarities to them. So we're going to go through answer these questions. Some of it, a little bit of a review, like what's a magnetic field? Can electricity make a magnetic field? What in the world is a right-hand rule? How can we concentrate a field to kind of magnify the forces that are there? And how does this all fit into being an electromagnet? And how can we make an electromagnet stronger or weaker? We've used the word field before, but electromagnet is going to be the new one we have here. So I'll get through this pretty quickly. Reminder, you can take notes on this. Please do upload them for extra credit into your Google Classroom. There'll be extra credits for your video notes and for your Edulastic/pair practice. All right. All right. Previous video, we went through what a magnetic field is, and remember that a magnetic field is simply the area beyond the magnet where the force of the magnet can be felt. The illustration that's on the screen, you can see the lines and the arrows on there. And again, the arrows are in the direction of what would happen to a north charge or a north pole if it were placed into this field. Which way would it get pushed away from, or which way would it get pulled into? So the magnetic force can exist anywhere in this field, and generally the closer we are to the magnet, the stronger the force is going to be. So previously we talked about a magnet itself making a magnetic field. However, one other thing that can happen, and hopefully you saw this in your PhET simulation, is that an electric current can also produce a magnetic field. How fascinating. So just like a magnet can push and pull things away, moving electricity can do the same thing. Now, unlike a regular magnet, this depends upon the current moving, which means that if we take the current away, the magnet kind of also goes away. So this is kind of a temporary magnet as opposed to what we saw with a bar magnet. In terms of the direction of the field that gets made around it, because it's a little bit different than a bar magnet, we can use this right-hand rule. Hopefully if we have a right hand, we can put this up in the air, and we can get an idea of which way the magnetic field goes by simply using this rule. So in this case, our thumb is going to be the direction of the current, depending on which way it goes. If we had a wire going up, then the thumb would be pointing up. If we had a wire going down, it's going to be pointing down. And the direction of our fingertips, or the way that we've got our curled fingers, tells us the direction that the magnetic field is going to be made in relation to that current. So as the illustration is shown, if the current's going up, the magnetic field wraps around kind of counterclockwise to that. And if the current would be going down, then the magnetic field is going to be going clockwise around it. Now, one of the things that we can start to think about with this is if we, instead of having a straight wire, if we have a looped wire, then the magnetic field is not just going to be going in a circle around the wire, but it can be going and concentrated in the middle of that wire. So the illustration that you have on the screen, it shows a wire, and if you had a current going through it, then there's going to be a magnetic field around all parts of the wire. And so inside the middle part of the wire is going to be lots of magnetic fields. And in fact, kind of what's happening here is those magnetic fields are going to magnify one another. If each portion of the magnetic field has a little bit of a force, then more and more of them are going to have additional amounts of force. In practice, what we can do with this is create an electromagnet. This is one of the things, again, you saw hopefully in the PhET simulation, that if we have a current that's moving through a wire, then that's going to produce a magnetic field. And so then if we actually stick something in the middle of that magnetic field, so in the middle of all those loops, if we stick a piece of metal, particularly one that's got iron in it, actually we kind of need one that's got iron in it, because remember, iron has domains in it that will kind of move around. So if we stick those domains inside of a magnetic field, all those domains will start to point in the same direction. And again, that's what makes a magnet to begin with. So sticking an iron nail or any other piece of iron in the middle of a bunch of loops, as long as some electricity is moving through it, We'll align the domains, and what that's going to do is to make our nail into a magnet. So it's no longer going to be just a regular piece of metal. It's going to be magnetized. And again, this is going to be a temporary magnet, because if we turn the electricity off, then the magnet's going to stop. Now, there's several ways we can make this magnet stronger. Most of these probably are common sense, since it depends upon electricity and loops and a metal. If we make more of any of those things, generally we're going to get a stronger magnet. So if we get more wraps around the nail, so in this case, it looks like there's about 8 or 9 wraps. If we doubled that, we should be able to make the magnet stronger, because we've got more loops producing more magnetic fields. If we up the voltage in the battery, that should up the current through the wire, and that's going to make things a little bit stronger as well. Additionally, if we have more iron available to us, like with a thicker nail or a thicker piece of metal, there's going to be more domains to align, and that should also give us a stronger magnet with that. Electromagnets can be used in a lot of ways, because one of the things that happens with an electromagnet, again, it produces a magnetic field, just like a regular magnet does. And any kind of magnetic field is going to push another charged object that might be in that field. And so in particular, if that magnetic field is allowed to push something that can move or to spin, then we might be able to do some things that are quite useful with it. Again, as you saw in your PhET simulation, like generate electricity or create a motor. And this is kind of the basis for how a motor works. Some of us saw that with the lab activity we tried with the battery and the wire, of trying to get a magnet and electricity working together to create motion. And so kind of the next thing and the last thing we'll hit with this little unit here is just to discuss how a motor works, and what are some practical applications for this. You can find electromagnets in all types of things, again, all throughout your house. A lot of mechanical things that we have, speakers, computers, a lot of these things use electromagnets to harness the kind of the power between electricity and metal. And one of the things, again, about an electromagnet compared to a regular magnet is there's kind of an on and off switch. So a bar magnet is always a magnet. An electromagnet is a sometimes magnet, and there's applications where we want to have one or the other. Oftentimes with an electromagnet, it's nice to be able to turn the magnetism on and off, but with a bar magnet, sometimes we want the magnet to be working all the time. We don't necessarily need an on or an off switch. So there's practical applications for both of those. So back to our questions. Hopefully, again, we understand a little bit better and remember about the magnetic field. We hopefully know that moving electricity can make a magnetic field. The right-hand rule gives us an idea of the direction of that magnetic field. We know that we can concentrate the magnetic field inside of a loop of wire. And if we stick some iron-based metal inside of that wire, we can get an electromagnet, which is temporary. If we have more wire, if we have more current, if we have more metal, we can have a stronger electromagnet, and then we can use those to hopefully start making some applications of things like motors and such. Thanks for joining me.